Welcome back. Here's the second half of 6.1. Just to quickly recap, in the last lesson, we said that the derivative of sine x is cosine of x, and the derivative of cosine of x is negative sine x. And all the other rules that we dealt with, the addition rule, the subtraction rule, the constant multiplication rule, they all apply as well. As it turns out, there are some other rules that still apply, including the chain rule, the product rule, the quotient rule. They all apply. So we're going to get some practice applying some of those in this lesson, some of the ones that can be a little bit tricky to navigate our way around. So let's start with some chain rule problems. So with this one, we have cosine of 3 of x. To find the derivative, again, our first thing is we have to find the outside function and the inside function. So the outside function in this case, well, actually, let's start with the inside function because we said finding the inside function is easier. So 3x is going to be the inside function. Then the outside function for this one would be cosine of x. And then we just have that 3x in the place of it. In fact, just to make it a little bit simpler, let's call it cosine of u, just because sometimes we dealt with that in chain rule problems, especially when we were talking about Leibniz notation. And then we have u equals 3x. So our outside function is cosine of u. Our inside function is 3 of x, is 3x. So chain rule says that we differentiate the outside first. So let's take the derivative of the outside function, which is negative sine of u. And then we multiply it by the inside function, by the derivative of the inside function. So u prime, or in this case, it's going to be 3. So this is going to be negative 3 sine of u, or negative 3 sine of, we said u was 3x. So the derivative for this one is negative 3 sine 3x. Let's try another one. So now we have 2 times sine of pi x. And just so we're clear, we have pi x inside the brackets. So oftentimes with these, the inside function is going to be the part that's inside the trigonometric function. So in this case, let's say the inside, we're going to call it u, is going to be u equals pi x. And just remember that in this case, pi acts like any other coefficient, like 2 or 3 or 5, just because it's also a real number. So just don't forget that. So then we're going to have our outside function, which is y equals 2 sine of u. And don't forget there's a 2 on the outside this time. So now that we have that, let's try and differentiate that. So y prime is going to be equal to, we take the derivative of the outside. So 2 sine of u is going to be, that's going to be 2 times cosine of u. So that's going to be 2 cosine of u times the derivative of u. So in this case, u prime is going to be, that's a linear, it's just 3.14 times x, so it's going to be the slope, which is just pi. So that's going to be 2 pi cosine of u, or fill in that u, it's going to be cosine of pi times x. So that's how chain rule works. So as a good general rule with trigonometric functions, usually you're going to find the inside function within the trig ratio. So kind of use that to help you kind of define where the inside function is and where the outside function is. Because thinking back to chain rule, that was the most difficult part, right? Trying to determine what's the inside and what's the outside. So as soon as we got that, the chain rule is not too difficult. Let's deal with something a little bit different. This is called the power of a function rule. Essentially, it's just kind of the chain rule in disguise, and you'll see why in just a second. So let's take example A. It says y equals cosine cubed of x. But we know we can just rewrite that as y equals cos of x cubed. So in this case, we can think of it as y equals u cubed, and u is going to be equal to cosine of x. So in this case, cosine of x is the inside function. So it looks a little bit different, but the same basic principle. So let's start by same place where we always do with chain rule, because this is essentially a chain rule problem. So we're going to start by taking the derivative of the outside function, 3u squared, and take the derivative of the inside function, negative sine of x. So that's going to be, let's simplify that a bit. Negative 3u squared times sine of x, or negative 3, and we said u is cosine of x, so it's going to be cosine of x squared, but we know we can also write that as cosine squared of x sine of x. But since we usually like to have the sign first, we're going to rearrange that. It's going to be 3 sine of x cosine squared of x. Doesn't really matter too much, but just slightly better form depending on who you ask. So let's try another one. Question B is y equals 2 times sine cubed x minus 4 times cos squared of x. So here we have two different problems. We're going to differentiate them separately. So same basic thing. So let's start by rewriting this so that way it looks a little more manageable. So something like that. We're just going to rewrite them so that way the power is on the outside so we can see this a bit more clearly. So for the first part, we see that the inside is sine of x and the outside is going to be 2u cubed. Something like that. So when we differentiate the outside, we're going to use chain rule again. That's going to be, let's see, 2u cubed becomes 3 moves out front and multiplies with the 2, and we get 6u squared. And then we multiply by the derivative of the inside function. That's going to be cosine of x. So that's for the first part. And since we've already used u, let's use a different variable for the other one. Let's call it v. So the outside here is going to be 4v squared, and v is going to be equal to cosine of x. So our outside and our inside. So let's differentiate that really quick. So 4v squared, that's going to be 8v times the derivative of v, which we know to be negative sine of x. So now let's clean this up a bit. We're going to add in our u and v. So u was sine of x, and it's going to be sine squared x times cosine of x. And then we have a negative 8, and we have a negative in front of the sign. So let's just clean that up right away. Negative 8 is going to be positive 8. And we get v is cosine of x times sine of x, which we can also write as sine of x cos of x. But you also see that we have some factoring that we can do, so let's just clean it up a bit more. So we could factor out a 2, we could factor out a sine x, and we could factor out a cos of x. And let's see, that's going to be 3 sine of x plus 4. And that's the derivative. So again, not too much different here, but same basic rules apply. It just looks a little bit different. So again, just keep, just kind of use your know-how, try and make the functions look however you need them to, and the differentiation rules will work no matter what type of function you're using. Let's try something a little bit different. Now we have product rule, which again works the exact same way. So for the first one, part A, we need to find the derivative of h of t. So we have two functions multiplied by each other. They have 1 and we have 2. So again, the rule is that we take each of the functions, multiply it by the derivative of the other function, and we add the two products together. So let's see. We're going to have t cubed. Let's see. Cos t is the derivative is going to be negative sine of t. And then we have the derivative of the first function is going to be 3t squared times cos of t. So what that looks like when we simplify it a bit, that's going to be negative t cubed sine of t plus 3t squared cos of t. And of course, we can factor out a couple of t's here. So let's factor out a t squared. And that becomes, you know what? I like to have the positive up front. So we're just going to flip those two terms. And we're going to put that one there and that one there. And it becomes, let's see, that's going to be 3 cos of t minus t sine of t. And that's the derivative for that function. Let's try another one. Now we have h of t equals sine of 4t times cosine squared of t. So this is going to get a little bit messy here. Let's see. That's going to be, let's see, if we take sine of 4t and we take the derivative, that's going to be chain rule. So that's going to be cosine of 4t times 4, or 4 times the cosine of 4t. And then for the other one, that's going to be, that's the same as saying cosine of t squared. So the outside function is going to be u squared. So 2 times cosine of t times sine of t. Negative sine t. So that's going to be negative 2 sine t cos t. So now that we have that, we have the derivatives for each of those functions. Now we can take the product rule. So let's take the first function, sine of 4t, and we're going to multiply by the derivative of the second function, negative 2 sine of t cos of t. And then we're going to take the second function, cosine squared of t, and we're going to multiply it by the derivative of the first function, 4 times cosine of 4t. So now that we have that, let's simplify a bit. For the first one, we have negative 2 times sine of t times sine of 4t times cosine of t. Then we have plus 4 times cosine squared of t times cosine of 4t. And of course, we can do a bit of common factoring here, and we want to have the positive out front anyways. So let's common factor out a 2 cosine of t. And we're just going to flip those. Let's do the one with the coefficient of 4, the second term first. That's going to be 2 cosine of t times cosine of 4t. And then we're going to have minus, the 2 becomes a 1, so it's gone. And we have sine of t times sine of 4t. And that's pretty much all you do there. So as you notice, when we're throwing in multiple differentiation rules, like chain rule and product rule into the same problem, and adding trigonometric functions. It takes a bit of work and know-how to get them simplified, but it's still not too difficult. It's just a matter of working your way through the problem and just making sure that you're careful with your algebra and your arithmetic. So let's try one more problem. So example 4 says determine the equation of the tangent line to the graph of y equals 2 sine x, or sine of 2x, I should say, at the point where x equals pi over 4. So start it the exact same way as any other equation of a tangent line problem. We're going to find our m and our b. To do that, we have to find our x and our y, and then find our m, and then we can solve for b. So let's start with x equals pi over 4, which we already are given. And then, let's see, y is going to be equal to, we're just going to take that function and we're going to, it's going to be 2 times x, or 2 times pi over 4. That's going to be sine of pi over 2. That's going to be the sine of 90 degrees. So that's really simple. That's just going to be 1. Now for the slope, we're just going to take y primed at x equals pi over 4. So to do that, let's find the derivative really quickly. So y prime is going to be equal to, in this case, we're using chain rule, and that's going to be sine of u, where u equals 2x. So 2x is going to be our inside function here. So let's take the derivative of the outside function, cosine of u, and multiply it by the derivative of the inside function. So that's going to be times 2. That's going to be 2 times cosine of u, or 2 times cosine of 2x. So that means that in this case, we're solving for m. We're going to find the 2 times the cosine of 2 times pi over 4, which is 2 times the cosine of pi over 2. But we know that's the cosine of 90 degrees, so that's just going to be 2 times 0, or 0. So now we have our x, we have our y, we have our m. We can solve for b. So let's plug in that information. So y equals 1, m is equal to 0, x is equal to pi over 4, plus b. So in this case, that's going to be 1 equals 0 plus b, or b equals 1. So now that we have that, we can conclude with the tangent line. So in this case, the tangent line y equals, m was 0, x plus b is 1, or it's y equals 1. And that's pretty much all there is to it. In fact, I'm going to guess if it's y equals 1, that means it's a horizontal line. So it means that we've reached a maximum or minimum point on our trigonometric function there. You can verify that if you want on Desmos, but I'll tell you that is the case. So hopefully that helps to make a little more sense of these differentiation rules as they relate to trigonometric functions. Again, it's all a matter of practice and getting comfortable working with these types of formulas. So just keep at it, keep working, and by the time we get 6.2 and we're dealing with applications, hopefully you'll be rock stars with this. So thank you, everyone. Happy practicing.